Sahrai and I'm from MIT. I'm here in Batteries conference to present our research on crashworthiness of batteries. We model cells and modules and battery packs to study what happens in case of a crash if we're going to have a short circuit at certain deformation, and that is helpful in designing the protection around the battery and to optimize the structure safety in case of accidents. Thank you.
Science degrees in mechanical engineering from the Chevy University of Technology and East University of Technology, respectively. She is the recipient of many prestigious awards, such as SAE Miles Award, Staff Student Award, and UTS Scholarship Award. We are looking forward to your presentation on crashworthiness and internal short modeling of Hodge and cylindrical lithium handsets.
From what you heard probably during these past 3 days, because it is more into research rather than production manufacturing. We research the area of crashworthiness of batteries, which is an area less research compared to electrochemistry and thermodynamics. One thing that is for sure is that vehicles are going to crash. We cannot avoid vehicle accidents, even if we have great advanced like prevention or lane change or brake assist. Still we have a lot of crashes. When a vehicle crashes and it is severe enough, we have to be sure that the battery pack will get damaged too. So in some cases, the manufacturers try to consider the battery pack as a rigid box and protect it with a very rigid structure. But we have seen like what happened in case of the crash test of Chevy Volt or recent Tesla accident, that battery packs are getting damaged too. So what our research is intended to do is to understand what level of force and deformation a battery can go into without reaching short circuit. And understanding that will help us to design our battery pack and the protective structure in a way that we optimize the safety of the battery pack. And we don't consider inside of the battery as a rigid box and try to protect it from outside, but we try to design our arrangement of cells, modules, and our protective structure in a way that is optimized in a crash situation. From the smallest scale, when you can identify which type of electrode, separator, coating method is like most resistant in case of a crash. It can help us to choose the right type of shell casing material. If it is a rigid, if it is cylindrical or prismatic cell, we have a choice between aluminum, steel, or composites to hold our batteries. And it is very important what type of enclosure we use, because if you just consider making the cell very stiff by using a very high strength steel, and the cells for our final element models, we do a lot of testing. Some of the tests are shown here, and you can see here one of the basic tests that we use on most of the pouch cells, this fixture, and then this applies a uniform pressure to the cell, and we measure the load and displacement, and this test test is very useful in calibrating the stress-strain properties of the cell. Similar to this test is performed on cylindrical cells when we remove the end caps and put the cell between two flat plates, and you can see how it is performed, and we get again the no displacement, and we use analytical methods to get the stress-strain curve out of this test. But the other test that we use is local indentation. You can see here different type of indentors that we use. This is a sharp conical indentor. This is a small cylinder or aluminum, or the cathode, which is having a current corrector of aluminum. And then we have the failure of copper, or our anode, and then we have a large deformation before having a failure of separator. So we get our material from a large automotive size cell, and we also have research material that we get from commercial sponsors.
Representing Maxwell Technologies, and we are a high-tech company producing ultracapacitors. Our company is based in the United States with a headquarter. We are as well having a representative in Europe and in Asia from the sales and marketing. We are producing the technological, the best ultracapacitor on the market. As I said, it's all about recuperation of energy, start-stop systems, which are picking very quickly up on the vehicle market, generally on the transportation market. But we are creating standards in other businesses, like, for example, into the smart grids, into the commercial business, mining and constructions, where we see a very important market for us. Our supercapacitors are especially required due to their benefits to the customers, environmentally friendly, they don't require any maintenance. And for our product, what is specific is the fact that we are having up to 1 million cycles, which in these industries it's very important. So we also operate in extreme conditions, climate conditions, and therefore we consider that in this application, which I mentioned, ultracapacitors, especially the ultracapacitors of Maxwell, are very efficient and provide the right requirements and specification to these customers. Thank you.
Our company is Guangzhou Tinci Materials Technology Company. We are a materials supplier, manufacturer in China. We produce the products is electrolytes and also the upstream materials of electrolytes. This is lithium salts. As you know, we are the top 5 suppliers in the batteries materials electrolytes in China, and also we have the international clients such as European clients. But I'm sorry, I can't tell you the detailed names because it is a secret. And also Tianjin Lishan is also our customers. And we produce the materials for the Li battery, besides the digital fuels, also the power battery fuels, such as the EV battery and HEV batteries. The international market is very important for our company, and so that's why we come here to show our products and our and our companies. So, as you know, European market is very important. It is very potential for the power battery. We hope we can come here to have a new start for us to promote and develop the European company. So please.